I guess I'll give it a few minutes for the guys to come in. I'm gonna try out this new headset that I got to see if you guys can hear me better and not pick up the background noise because I'm printing something over there right now. Um, I use this mic for gaming, so it should pick up pretty well. Hoping that we don't have any drop frames today. My dad is watching TV upstairs. Um, Caught a big fish over the weekend, so he was happy. Um, and he's watching TV. He's feeling a lot better. Um, I guess I should apologize for not streaming for the last week and a half. Mainly because I've been working a lot on the cube design. I'm kind of switching away from the um, Ultimaker crossrod because I ran into some issue with racking on the linear rails, and I'm thinking of moving to Core XY actually. So that's what I ended up doing was to kind of working on both branches at the same time and see which one actually came out a bit better, I guess. Um, the I was just saying that I was apologizing for not streaming for a week and a half. I've been busy kind of reworking the design of the cube, the kinematics, and I just basically announced that I'm probably decided to go with Core XY over the Crossrod. I did some testing on the Crossrod, and the the racking is an issue. Mainly the trying to get both sides moving in parallel uh, on both axes is going to be pretty tough. I want to do a mic check. I'm using a new headset, so I want to see if you guys can hear me okay. Um, the and having four motors and trying to synchronize them is another issue. So, um, wanted to sort of cut down on the parts count as well. So, decided to kind of move to Core XY. Um, the resistance before I had with Core XY was the length of the belt and the the fact that the belt routing was very difficult to do. So I ended up sitting down. Let me show you guys what my thinking process, since you guys seem to like this so much. So I started to do some thinking about how I would route the belt so that in a dimensional space, how I would route the belt so that it wouldn't cross. So that was one of the um, big downsides to the original Core XY design was that the belt up in this area here would end up crossing because they go from the top to the bottom. For some strange reason, that was the original design. So I ended up using just as to visualize where the bearing location needs to be in relation to the AB motors and the dropping frames again. Hang on, okay, hang on. Okay, I'm back. Hopefully, I'm back. I went. Let's see if we get any drop frames before I continue talking here. Yeah, he fell asleep, so I'm just shut off his stream. Okay, looks like we're back. Okay, so I was saying, so I was using this diagram to sort of figure out the placement of the bearings in relation to the different clearances and stuff like that, and try to figure out where we need to go, and then kind of went from there to a more formalized drawing of the belt routing and how it would clear each other in 3D space. So that sort of helped to visualize what parts I needed to build and where things need to be. So it's kind of still kind of rough because I mean like some of this is kind of midair and it's kind of rough, but at least gave me the idea of how the belt weld is going to be. One of the big reasons why I'm hoping this will solve our racking issue is that this belt here, this line here and here, like I'm gonna highlight the one belt that runs. That's one belt run. So basically, it starts here. Oh, maybe I can show them a little more. It starts here and it goes over the motor, down to the side of the pulley, around this side, around this side of the pulley, the XY joiner pulley, and it ends up here. So what happened is that the when this motor turns to pull the gantry this way, it pulls both sides at the same rate because it pulls on two different points. So it should um, it should sort of synchronize the left and right side, and same with the reciprocal belt. Basically, the mirror of this belt. They'll if both of those are pulling this line and this line at the same time, it pulls the gantry this way in a synchronized manner. So, and then the fact that the other side is connected to the same carriage allows the slack to be picked up and move in the same direction. So, we should see less racking issue with the Core XY. Um, the one thing that I had to kind of solve is how to add in the tensioning of the belt, because that's the other um, main issue with using Core XY with or any of the like H-Bot and all the long belt systems is that um, it's hard to tension the belt because the belt has to it's just fairly long, and you really don't want to put too much tension on it because it stretches, but that you want to have enough tension so that it doesn't skip. So that's another thing that I had to kind of work on. So this is how I started about 2 weeks ago with this sort of three-dimensional diagram, and I started to start modeling the parts. Um, Staying within the existing frame that we have already spec'd out, it actually turned out pretty well because um, I was able to do it without changing the frame itself. So that was something that was nice. So this is the finished layout um, of the Core XY cube movement. So let's start on the, so actually it would be like this. If you're looking at it from the front, this is the front, and the motors are in the back so that they're out of the way. And we could have the wiring in the back and not have to worry about seeing those. So that's the back. But let's say we call this side left side. Let's have a look at the left side. So how it goes is the belt from the carriage passes through the XY. Well, this part here is called the XY joiner. So it basically joins the y-axis with the x-axis and allows the belt routing. So the belt just go through this pulley, makes a hot left turn around the motor pulley and around this idler pulley and goes around to the right side. So that's how it is able to pull this gantry this way, is when that motor turns counterclockwise, it pulls the gantry this way. The rest of the belt goes across the entire length of the front, ends up here, and goes around the lower pulley into the back of the carriage. So it started on the sorry, to the front of the carriage. This is the front. It started at the back, goes all the way around, comes around to the right side joiner and goes to the front right. So that the other the other one is reciprocal. It starts at the back right, goes to the top bearing of the XY joiner, goes around the right motor, comes back down and passes through the right idler, again flies all the way through the front, grabs, goes through the idler on the top, goes to the left joiner and connects back to the left front. So the belt actually, I was able to use. See, I just have the belt here. This is the belt for. Let me get the other camera. So this is the belt for about that long. I guess about 48 inches. That's all. That has enough slack in it for the for you to cut off some of the slack. But that is all the belt. That's one side, and that's all the belt that you're gonna need to run through it. So let me grab. Since I have to zoomed in, let me grab the parts here to show you guys what it looks like now, and then do I have the other? Yes, I do. Okay. Okay, so the the XY joiner. This is the first iteration of it. Basically, the idea was um, that um, it would have a extrusion sit in there like that, and then this would sit on the carriage, and then it would slide back and forth. That's sort of the first idea, just to get a rough estimate of how big it's going to be and so on. The problem is that I didn't budget into the design anywhere to put the pulleys. So then this was kind of the first fail. Like this is probably like version 4, because I'm up to version 70 right now. So that's version 4, and um, then I made this one, which had space for the pulleys, but then didn't have space for the 2020. So I had to sort of figure out, okay, how do I jam this in here so that I would be able to still rest this comfortably on the carriage and still have this in here. So that led to sort of, see, do I have the other one? I think I have one more revision between that. Okay, yeah. So that sort of led to this monstrosity. So the idea was that I would have the pulleys in there, and then um, I would sort of just bolt the extrusion like that, and it was gonna be a 2040, so it was gonna be like that. Um, but the problem was that um, it there was no keyway for the extrusion, and it was only relying on the through bolt to hold it in here, and that's why I wanted to go to 2040, because otherwise it would start twisting. So this was one of the like probably halfway into the design. This is sort of close to what the final ones will look like, and then I thought, well, it's not really gonna work all that well. And then this little thing down here was kind of like wasn't really pretty, and it didn't really work out for me. So um, then we ended up with um, this one. Let's go with this one. Ended up with this one. So I would have separate shelves for top and bottom, left and right bearings, and then um, built-in support for the hole. So what happens is you knock that out, of there, and you get this. Get a keyway for the extrusion to go into. So actually, it still uses a through bolt, but there's a keyway now that basically synchronizes the where it needs to sit in the XY joiner. So that gets knocked out of there. It's kind of rough in there now because um, the mounting holes for the linear carriage happens to be 2020 in a square pattern, or 2025 actually. So, but it was close enough that it was causing issues with the clearance issue between that and the keyway. So um, that problem actually go away later because we actually need to space out these pulleys a little bit on either direction. I'll show you guys why in a second, but basically we needed more space on the pulleys there. So this is I think like 68, revision 68, and the nice thing about this is that this is the printed orientation. So um, all these shelves are printed vertically, and the little bumps for the bearings actually printed without supports. The bottom big keyway, there's a support piece that using a little screwdriver in the counterbore here, you give it a little tap and it'll pop right out, and you don't need to rely on the slicer for support. Everything it prints as in place and is pretty good. There's nut traps on the bottom, and it took a while to figure out how to do this so that it doesn't require support and it prints nicely. Like originally I was going to print like this, but then the shells will require um, supports, and then the back keyway here would have been a nightmare to print. So I figured out the orientation is supposed to be like this so that you get all the nice features printed that way. The idler, again, it started life as a single idler for top and bottom. I was thinking I could get away with. That's what a lot of the people do is they use a single instead of a two column. They use a single column because the belt comes in at an angle that you could kind of get away with it. Um, is roughly 2 degrees or 3 degrees off axes once you get the length that you're looking at. I didn't want to take that risk of having the belts sort of cross later down the road, so went from that to the, and also it wasn't taking advantage of the whole surface here, so ended up taking a revision to this one that has the same sort of idea as the joiner. Has two shelves for top and bottom pulleys, and the way it's set up is it's got two columns that's close together. Um, so you would use one column or the other, depending on whether you want a left or right orientation. Um, you'll see that in a second. I'll make sure in the picture. Um, it it uses this one and this one, and then you basically flip it around and uses the other side. So the nut traps are always on the bottom. So I mirrored these parts so that the nut traps are always on the bottom and the screws on top. I'm debating whether if I really need to mirror it. I mean, it doesn't really matter if the nut traps on the top or the bottom, but the nut traps are there. Again, this one is the printed orientation is this way, so that the shelves are printed vertically and the bumps comes out nicely. Um, you, it's a fairly strong part. What was I gonna say? Oh, so I was only able to fit in four. Let's see it this way. I was only fit in four M6 bolts. for such a little part, I mean, for them, it's more than enough. It wraps around the. I use this 2020 as example. It wraps around the corner and it grabs both sides of the extrusion so that basically it's not going to twist. It's not going anywhere. So it's actually fairly fairly strong part. So that one actually didn't take that long to do, and that was one of her first stable parts that didn't really change much from there. Um, let's see. Oh yeah, like this one work. So this is some leftover Tiffany color PLA I had. So um, the motor mounts. So basically, the idea is that this shelf, the motor sits on it, and the shaft faces downward. That's how the belt is going to route it. Allows maximum flexibility to move it up and down the extrusion, because on one side, um, you're going to need to go a little lower than the other because the pulley needs to make sure that the belt runs parallel um, to the linear rail, so that you kind of want to need to adjust the height of the motor mount. Again, this is one of the early parts that kind of became stable pretty quickly. I mean, all it is a NEMA 17 mount with a fancy curve so that it basically is like acts like a gusset. I might put something in here to kind of take out some of the material. It's not really needed that much. Printer orientation is this way. Um, Minimal bridging on the part here. I was in this one. I was actually able to fit in three on the vertical and two on the side profile. So the it again it's designed to kind of go around the part the extrusion so that it gets it on both sides, prevents the twisting. The it's fairly tough part. I mean, like is um I had to this one I had to mirror because basically the idea is that the this is the inside face. Same with the idler. The idler, this is the inside face. So the 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 protrusions that go into that needs to, because this big is wider than 3030. The protrusions go into the printer that are not outside of the 3030 boundary. Um, I know that certain people, like who like, let's say Donald's gonna build it with 6060, then I have room in the other side because it's 6060, but I just want to make sure that I stay within that boundary so that like um, the stuff is on the inside and it clears the vertical slot for the wall for the 6060. That was important because I needed to make sure that works for them as well. Um, what else did I work on? Oh, I can show you this. This is that. This is the part that I whipped together. Um, it's designed like I think I mentioned this on the last stream. It's designed so that you would use this again an example. You would put the linear rail on top of here, and you would just plop that on there like that. On a 3030, it'll be a little tighter. On the 3030, it's a little tighter, and then you basically slide this carriage down. And what happens is that the grooves inside, you can tell from there, it aligns it to the middle of the 3030. And then the three holes on top is the standard spacing for the linear rail holes, so that basically the idea is that you slide it along, and then you would use the top access holes to bolt down the rail as you slide it along, and then you push downward on it. It keeps the rail in the middle, keeps it down, keeps it in place. So this came in pretty handy when I was putting together the linear rails on the 3030 for the cube. So I know that some of, like I know Donald did, is bought 4 rails and 4 carriages and a bunch of stuff. Um, Good news is that he could probably print by you could probably build 2 printers now, because right now with XY we're only using 2 rails on the left and right. The cross rail I'll show you guys in a second is it's gonna be a 2020. I'm debating. There's 2 different options. I'll show you guys in right now. Let's have a look. So this is the part. Um, Let me see if I get a good angle here. Maybe the front angle is a bit better. Okay. So this part here is from IGES, and basically what it um, is a carriage that has 4 sides. So one of the problem with linear rails is that you have a top surface, and then you have the side profile, and that's all you're writing on, and on the rails. So what happened is that, let me just go back to FaceTime. So what happened is um, let's see, when you have a sort of like a long load, it this downward force, like I'm exaggerating the downward force of it, but you could tell the downward force here puts pressure on the XY joiner to go downwards, and that crookedness of the XY joiner puts pressure on the carriage, and they call that torquing. So not the NSA torquing, but this is the torquing of the bar against the XY joiner. So um, we sort of eliminate that problem because we got the keyway, we slotted it, and then we got key supported on both ends, and it's fairly stable. I think this works though, no problems. But then when you get to the middle, what happened is that if we were using a standard linear rail and a carriage, there's gonna be some kind of L overhang that you need to do to get the extruder or the carriage to move back and forth here. Or some guys put the linear rail on the vertical surface. But the problem is that even the regular high wind rails, not just the IGES, is now all the force is on the side profile of the running the carriage sideways. The Normally the carriage, if you ride on top, is sitting on the largest surface, right? I'll show you guys a picture of it later. It's like riding on the largest surface. But if you put it on vertical, it's riding on a very thin strip of material, and basically that's not good either. So this compromises on both ends. The L has issues with torquing and then alignment. You need to sort of figure that one out. So with IGES, um, let me go back to here. You get a good view. Let's move this. So with IGES, what they did is the entire inside of this cavity here is um, uh, material, like the bearing material. So maybe if I could get a, see if I can get a picture of it. Give me a second. So the idea is that it has no torquing issue because all 4 surfaces are treated as has the bearing material in it, and it's designed that way. It's designed to be used that way. So let's see. They never get a good picture when you leave one. It should be. Uh, this is similar. Let me show you this one. Um, uh, Give me a second. Let's get this sorted out and go show this one. So That's a bad picture, but you guys get the idea. Basically, there's material on all four sides. That's one of the older models. Um, yeah, I wish they had shown the uh a better picture of it. I guess it's as cool as we're gonna get in terms of picture. Um, anyway, the idea is that this carriage, oh, that's a bad picture too. The carriage has material on all four sides, so and then there's doesn't matter which side is loaded, meaning has a bearing a load, it it will be riding square on the tube itself, and the bearing surface on all four sides is equal. So, you don't have this problem with the that you will encounter um with the linear rails carriage, the regular linear rail carriage. So, let's do that. See, maybe show that one. Let's see. Oh, oh, this one's a good one. So that one is it just shows a better picture of what the linear rail carriage was like. So there's only that's the the bearing material. So if we had this in the horizontal orientation, you have this strip and this strip to offset the load. But if you are hanging it vertically, you're gonna put all the weight on this one strip. The other one is just sitting there doing nothing. So over time it's going to basically wear down that one particular strip, and you're going to have all sorts of fun issues with it. So it's not really meant to be run vertical. And then on horizontal wise, you like I said, you have that problem with a load hanging off the side, which is again going to put pressure on the one side versus the other. So um, on in our case, because we're running parallel carriages across the gantry, that is the correct application for the linear rails. Um, maybe I could show the. There you go. That's a better picture of this. What's inside of the drying cube? That's what they call it. The drying cube carriage has the bare material on all four sides, so that it equally distributes the weight. So that's enough of that. Let's go back to this here for a second. So um, one of the things that I was talking to Donald about was whether or not we need to go with 2020, because 2020 is nice. It's nice and sturdy, but it might be a little overkill for what we want to do. So they do sell a um, kind of this the smaller brother, which is the this one I'm popping up on the screen here. This is the 12 millimeter version. Um, the smaller brother of the 2020 version. Has the same adjustability on all three corners. So most of these are adjustable on the three corners. So what they do is they have one corner that's kind of the constant, and they adjust the clearance between these two corners, and then the clearance of the left two, so that that's all the adjustment you need to get it going. In terms of like slots and stuff like that, the smaller cousin actually has a bit more slots. I mean, if you look at this, it has one slot here, and one slot in the middle, and two slots on top. The reason why I like the smaller one is that there's two slots on this side and two slots on this side. So if I'm running it kind of, if I counterclockwise or clockwise, 90-degree turn the carriage, I get two slots. And because remember, I told you that I have belts that run on top and bottom. I need anchor points. So having two slots on both sides is actually perfect for me. I try to think about doing that for. Let's get rid of this rail so we can see it, and then let's get rid of this rail. So this is what I was talking about. There's two slots here, and one slot on the bottom, one slot on either side. So I have to sort of have a printed part or something to so that I could bolt on two belt anchors. But this one, the 12, the 12 by 12, I have two slots. I just have to rotate this 90 degrees, and I got two slots that I can actually just anchor the belt to. So I sent the email to I guess and asked them for a 500 millimeter span. Do I need to? Is 12 millimeter enough for the 500 millimeter span that we have across the two sides here? And I might just give it a try, see which one works better. The other issue that I'm kind of running into is let me just tilt this a little bit more like so. You see that the belt exits here and here is going to go directly into these two profiles here. So that means I have to make this carriage, the XY joiner carriage, longer so that it ends up being on this side on the right and this side on the left. So I have to make the carriage longer, which cuts down on the Y travel, right? Because I had to somehow make the belt go around the wider carriage. But with the 1212, I don't have to make as big of a change. It's just it still have to make a change, but I don't have to make as big of a change. Somebody tell me what was the last thing I said because I think I just dropped a lot of frames back there. Okay. All right. Well, I'm not sure where we left off when I dropped frames. Um, Anyway, so let me just recap. So basically, I was saying that the this I guess carriage on the left here ends up I have to do wider XY joiner in order for it to clear the belts. On the right side, this one here is a little narrower, so I can actually get the belt just slightly over and around to the where the carriage needs to be. So um, I think if they come back, if I guess comes back and says 500 millimeter span with um, with the 12 millimeter square frame is good enough. I think I'll probably try that for the first reference build before we go with the 2020 because the 2020 is nice, but I think the if we get away with a 12 millimeter, it's a little neater looking too. It's a little bit slicker looking. I mean, if you look at it, it's roughly the same height as the XY joiner, so roughly the same height as this job. So hopefully it will fit within the confines of the carriage a little bit better. So um, let's go back to FaceTime since I'll show you some stuff. That is the work in progress of the Haribo Cube. You can see um, the 2x3 corner brackets. They're really meant as alignment brackets only. The actual structure is same as the Haribo 3030. It's the through bolt on both sides. The issue is that this is a more three-dimensional design with crosses. So the problem is that the one L covers the other L. Um, so there's actually a procedure for fitting these corners, and in addition to an L that um, aligns the vertical with the horizontal, inside the L joint goes one of these doohickeys. Um, so basically, on every inside corner, there's a bracket. On every outside corner, there's two L brackets that align the vertical with the two horizontals. MA through bolts through the corner on every corner. So I counted the number of M6 bolts. Each one of these corners takes 10 M6 bolts and 2 M8 bolts to hold this corner together. I tried to move this thing once I got it all like assembled. There's no way that this thing is gonna move. Like, it's solid as a rock. It's basically, think about it. This 1, 2, 3, 4, 5, 6, 7, 8 corners, right, on a cube. I have to count that. There's 8 corners on the cube. Each one of those take 10 M6 and 2 M8s on each corner. So I actually ended up running out of these T-nuts. I ended up running out of them because you think about it, that's 80, right? Like, so that's 80 T-nuts just for the corners. And then I needed 4 for the idler, so that's another 8, and then 10 for the 5 and 5 for the motor mount, so that's another 10. So that's another 18 plus the is that yeah, 18 plus the 80, 98. So as of this count right now is 98 T-nuts just to put this thing together. To where it sits now, I mean, it's not even complete. It's the way it sits is 98. Um, plus, we need 6, so 12 for the bottom Z, and then another 8 for the top. So 20 more just for the Z motor mount and the Z mount, plus whatever else we're gonna do. So um, I think we are at 68 nuts when we built the Haribo 3030. We are close to almost double the number of T-nuts on the cube. Um, yeah, it's crazy. I mean, the way it's used, and I really, these are sort of again used because I'll have to document the procedure. These are used to hold the extrusion in place because there's a bit of back and forth on removing an L, bolting the other axis in, putting the L back, switching to the other one, bolt it in, put the L back. Because the up here, the two L's cover each other in terms of the bolt hole. So you kind of have to play around with the procedure, but once you do that, it's solid. I mean, there's a different way to do it, or I could redesign the L's, but then it won't be as strong and it won't be as nice, and because I want to kind of make it look the same top and bottom. So that's something that I wouldn't want to stick with. It's fairly heavy too. I mean, I know I'm kind of reaching over to pick it up, but that thing is a beast of a frame. Right now, I tell you, it is a beast. Um, anyway, that's what I've been working on. I mean, like for the last 2 weeks is basically updating the kinematics of the printer. Um, yeah, some of these parts, unfortunately, for the cross rod, I'll have those. I'll probably still release those if somebody wants to kind of take take the time to actually make them work. I mean, I spent all the time on it, but didn't want to go to waste. Yeah, this guy back here. Um, yeah, I printed that. This is the eSun PLA. That was on sale at Filaments.ca. No affiliate links. Um, it was $25 for the filament. The only problem I found with it was that it under extrudes like crazy. Like the same setting I use for the Filament.ca stuff, I have to go up to like 103, 104 extrusion to get the same infill, like the same filling as um the Filament.ca stuff. But at the price, I mean, $25, snow pesos is not too bad. So decided to get a few rolls to print those guys. Um, yeah, I guess you can't really see it, but I had to whip out the PC laptop, the Windows laptop to flash the firmware. I just couldn't get it working with the with the Mac. So yeah, this is a little bit artifacts. Like here, you could um, where the line starts and stops, and there's a little bit of overhang push you here. But yeah, this is the way it came off the printer. Like it's like here, you can see right here is like where the line stops. But overall, I mean, I for me, I'm not really complaining about it. People should know this is a printed part. There's these little artifacts. That's normal. So, but coming off the printer, the way this sits, I can't really complain about it. Yeah, free. So if you got filament from filament.ca in the last few weeks, they were sending these out. This is their own house brand of um the cleaning element, the cleaning filament. So you know they make it here in Canada, so no pesos. So um, I got some. If you guys want it, just hit them up. They'll put them in a package for you. Um, that's actually a lot. That's actually probably enough for a few. Um, I guess every time I do, I think he woke up and went back and started watching TV again. But yeah, that's more than enough for most usage to sort of switch between different colors. So that yeah, so I've been having issues with the internet. Bell came by and said they want to offer me fiber optics, so I might go with that. I'm not sure yet, but um, the yeah, I was saying hit them up if you want it. I mean the if you order one or two rolls from them, they'll throw this in for free. So this is pretty good. I think they want like $10 if you want to buy it separately. I know you want to see this again. It's kind of like the light reflecting off of it is sort of you could tell there's some banding here. Um, but overall, like I said, I'm happy with it. It's fairly smooth. You could see the light shining off of it. It's not a lot of. There's a little bit artifacting like here where the slicer stops and starts the line. Like up here, like right there. You see that? Yeah, that's where the line starts and stops. So um, yeah, what I found was that like I I'm uh, I'm on cable right now on cable internet, and the well that's PLA, Esun PLA. I was saying that Filament SCA had a sale on these with like 24, 29, 99. I think if I have to have it still, probably somewhere. No, I don't have a box of it, but basically it was Isan PLA. It was 25 bucks. Snow pesos, so it was a good deal. I mean, that's like what, $5 can US. So, um, what was I say? I lost my train of thought. Usually, wow, yeah. PTG. Yeah, we dropping frames again, so I'm just gonna finish up. Basically, no, since we're running out low on time, no shopping this week. Normally we go on AliExpress and like go and talk about different things. I did get a good code. I know this sounds bad. I got a good coupon code. I'll share later down on the bottom from a friend of mine I met locally. He's a Canadian CL10 Facebook group admin, and he got a good coupon code for CL10. I think it was 500 and change Canadians, or 500 something snow pesos for CL10 shipped to my door DHL 2 days. So I asked him for the code. He shared it with me. I'll share that with you guys because I think he said it's like 380 odd dollars US. So awesome deal if you guys want to get a CL10. I'm not gonna say it. I mean, you guys can probably like you guys probably want me to say like, oh, I hope to get a CL10 soon for review or something like that. But no, I'm not gonna say it. Oh, new glasses. So just in case you guys wondering why it looks so different this week, is got the new glasses. So um, yeah, I think makes me look a little bit more nerdy. So um, yeah, Anthony. So it was actually less than 429. That's what I'm trying to tell you is that it's 510 Canadian shipped to my door. So if you already got it, sorry, but if you didn't, let me see if I can get your code so that you get cheaper. Yeah, he said 510 was like the lowest he ever seen it at, and it's two day shipping. So you get if I order it Monday, he said I'll have it by Wednesday. So much better deal, I think. Um, anyway, I won't babble on. Again, I apologize for not being on for a week and a half. I'll try to I'll try to be more regular in terms of the now that I'm caught up with the design, I'll be a little bit more regular. Today's Friday, so I'll try to do something Sunday just to make up for the last 2 weeks. I'll get be a little bit more prepared. We do some shopping and we'll show you the CL10 and all that other jazz. I'll try to see like a set up a camera back there so I can show you guys the progress so far. Um, then let's say after Sunday, the next one will be Wednesday. Back to Wednesday, Saturday after that. Um, I'll try to keep the schedule. Anyway, thanks for tuning in. No, I didn't announce this. It's like a last minute thing. I just want to make sure that you guys know that the project's not dead. I'm not dead. Um, things are happening. It's just that I needed some time, alone time, to sort of sort out the parts issues. And I mean, you can't see it, but I got a box full of parts back here that I printed off the printer, and I'm trying it out, then junking it, redoing it, and so on. So, yeah, lots of progress. Just not the kind that not like it moves forward, but very slowly. We do a lot of different designs before we get to where we need to go. Um, but the end is near, as they say. So for the XY core XY pivot, that's what I wanted to say. We pivoted just like the guys um, in that favorite show of mine. Now I forget the name of it, but anyway, we pivoted and we went to core XY. So hopefully that works out well. Speaking of which, I will list the seller of these. flange bearings, because you're gonna need a lot of these. I mean, for each idler, you're gonna need like two, four. You need four for each idler. Silicon Valley, that's it. Yeah, Jared. Um, they you only need like four of these on each corner, plus the XY joiner and then the carriage. So you're gonna need a lot of these. So gonna need to get those. Yeah, this is Fusion 360. I did the whole Haribo 3030 on Tinkercad, and these guys were laughing at me how I was using some toy program to do it. So um, I just stopped, forced myself to um, tiny spinners. I stopped. I took a week. I forced myself to learn how to use Fusion 360, and the way I learned it wasn't really going with the tutorials. How I learned it was trial and error. I did a part, and then I looked at it and thought, "Well, that's a stupid way to draw it." And then asked, I think I asked Patrick, I asked Scobo, I asked a bunch of people, and say, "Hey, how do you do it?" Kind of get the experience that way, and then we draw the same part over and over and over again in different fashions to figure out what's the most optimal way of using the tool, and um, yeah, it works just fine. I wanted to go with SolidWorks because everybody says go learn SolidWorks, but I just can't afford it. I mean, Fusion 360 was free, so and then that's the other thing is it's also like I wanted to use a tool that I could help other people learn and help people use, and Fusion 360 seems to be a good step from Tinkercad, and I know other people use Onshape or they use SCAD, OpenSCAD. But then like I'm a programmer by trade, and I looked at OpenSCAD, and I thought, man, like the amount of work I would have to do to OpenSCAD to do some of these really really complex looking parts is just too much work. So sort of settle halfway, and then that went with Fusion 360. I mean, if it seems to work okay, people seem to enjoy it, and um, like I used to like be on twice a week and just kind of babble through about how I did a design and how the thinking process goes, and then show the different progressions and the failures and the pivots and the back and forth of the design. And I think I guess it's kind of corny to say, but it's these guys seems to enjoy the journey more than the result. I mean, they watch me kind of come up with the part and put it into the program and get it all working, and then figure out that like I missed something, go back and then redo it. I think that whole journey is more important, and we all learn a lot from that. Anyway, that with that last sort of drop frame, I think I'm just call it a night. Um, I will try to do these when he's not watching TV, and then I gotta call the ISP and say what the hell's going on because I should be able to stream and he watch TV at the same time, and I shouldn't have any issues. But that's life, right? First world problem. So I'm gonna go. Catch you guys Sunday. If I don't see you guys in chat.